teaching pre-calc and trigonometry, doing something mean to it. Teach it better than anybody you ever seen. Doing screams from my students, got a nice ring to it. I guess every super teacher needs theme music. Oh, wow. That's right, folks. We're ready to start into 1-3 graphs of functions. Wow, such a sweet intro. I bet nobody else intros or notes like this. Anyway, for 1-3, we're going to do some graphs of functions. We're going to find some domains and ranges of functions. Use your vertical line test. Vertical line test! We're also going to find intervals in which functions are increasing, decreasing, or constant. We're going to find some relative max and min values. We're going to graph step functions and other piecewise defined functions, and we're going to identify if anything is even or odd. So let's look at our first example. Here we have the graph of a quadratic function, also known as a parabola. And what we need to do is we need to figure out what your domain is, or what your range is, and we're going to evaluate f of 1 and f of 0. So if we want to look at your domain, remember those are your x values. So we want to look at how far does this graph go to the left, and how far is it going to go to the right. So this graph, even though there aren't any arrows here, we'll add some arrows. And this graph of this parabola, well, it never stops going to the right. We're going to continue moving all the way over there. So that means if we write this in interval notation, you're going to go from negative infinity, and then you're going to go, as you go to the right, this graph keeps going from -2 to -1 to 0, x equals 1 to x equals 2, and on and on and on and on and on and on. Continues going right. So it's going to go from negative infinity to positive infinity. So those are your x values. Now, if we want to talk about a range, these are your y values. And what we're going to get with our y values here is we're going to look at how low does this graph go? How low can you go? How low can you go? Well, this graph never stops going down because you have arrows here. Even if you don't have arrows, this is implied that it's going to keep going down. So the lowest y value you have is negative infinity. Well, this graph keeps going up and up and up and up and up and up. It goes to y equals 0, y equals 1, 2, 3, stops at 3, turns around, and goes back down. So the highest it goes is 3. And remember, if you include 3, you would put a bracket around it. You know, some people ask me, Mr. Klein, why don't you put brackets around infinity or negative infinity? Well, the reason is infinity and negative infinity is not an exact number. It's an idea. It's a thought that the numbers never end. So since you don't have an exact number where it stops, you can't put a bracket around a false number that's not an actual number we can see. So that is why, students. All right, let's go into part C. Now we need to find f of 1. Well, that means we need to find our y where x is equal to 1. So if we go here to where x is equal to 1, here's x equals 1. And you go up, 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 you find this point on your graph. Well, to me, it basically looks like f of 1 is equal to your y value of 2. So if we had to look at this graph and evaluate our function, we go to where x is equal to 1. This is your x value. Go over to 1, and you're either going to go down or you're going to go up. So that's where it's at, and you find out that your y is equal to 2. Now, if we want to find out where f of 0 is, that's x equals 0. You're going to go up and down where x equals 0 until you run into your graph right there. This would be 3. Also known in this graph as your y-intercept. Remember, your y-intercept is wherever your x is equal to 0. All right, so that does it for example 1. Hope you enjoyed your intro to lesson 1-3. Trust me, all these examples are just as exciting.